Hello everybody, welcome to your first lecture video for AP Physics. You're going to notice a few things about these videos. Number one, I record them in the back of the classroom, so if the light goes out, it's because I'm not moving. So every now and then I'll hop up and move so the lights will turn on. And you might hear some noise in the background. That's probably custodial service working in another room, but this is a one-take shot, so you will see me make mistakes, and hopefully you'll find some humor in it. So here we go. Well, before we get started, let me go ahead and define some terms here in physics. Well, normally in math, when you guys are talking about direction, you follow the Cartesian coordinate system, which looks like this. If you don't know, this is the x-axis. This is the y-axis. This is the positive direction, negative, positive, and negative. And what you normally learn is that if I move in that direction, it's positive, and if I move in this direction, it's negative. If I move up, it's positive, and if I move down, it's negative. Well, in physics, it is different. The initial motion, no matter what direction, up, down, right, or left, the initial motion is always positive. Then anything that opposes that is negative. So if I initially start out walking this way to the left, that is defined as positive. So if I initially walk this way, that's positive. If I turn around and go that way, which opposes this initial motion, that's defined as negative. So you're going to have to let go of this system that you learned in math and follow the rules for physics. And once we get along in the class, it'll be second nature to you. All right, so let's open this first lecture with the difference between distance and displacement. Well, displacement is what we call a vector. And a vector has two components to it. It has a magnitude, and when I mean magnitude, I mean it has a size. Is it 2 miles? Is it 2 meters? Is it 15 kilometers? It has a size. And a vector also has a direction. Is it positive or is it negative? So when I'm talking about a variable that is a vector, you have to pay attention to the sign. That makes a huge difference. And as we get further along in this, you'll see. All right, so displacement is a vector. It has a magnitude and a direction, and it is defined as the change in the position. Change in the position. So we have to pay attention to the direction. Is it positive or is it negative? So let me give you an example. Well, first of all, let me define the equation. It's really simple. The displacement, the variable is an x, and it is defined as the final position minus the initial position. So I got this rudimentary example right here. It is a guy, my stick man, and I put a number line out here just to make sure you can follow along with the example clearly. So let's say my guy starts here at the -3 position, and I'm defining this as -3. -3 could have been over here. It doesn't matter. But I am defining in this example that -3 is over here. And you can do that. We have that option. So he starts here at the -3 position. And he moves to the right to the +2 meter position. And then turns around and moves back to the left and ends up at -1. So the question is what is his displacement? Well, according to the equation, the displacement is the final position minus the initial position. So my final position is at -1 meters minus the initial position, which is -3 meters, and I end up at 2 meters. And in this case, it is 2 meters to the right, and so we end up here at this location, 2 meters to the right. It has a magnitude of 2 meters, and it has a direction, which I signify as positive, and that is to the right. So now, let's take a look at distance. Distance is a scalar, which means it only has a magnitude. It doesn't have a direction associated with it, just a size, just a number. And this is a rudimentary definition, but I think it kind of makes sense. And distance is just the amount covered. If the object moves over that amount, then you add it all together. So if I go back up to my example up here of this guy on the meter stick, or right here on my number line, I can see first he moves 1, 2, 3, 4, 5 meters. Then he turns around and he moves 1, 2, 3 meters. So in all, the distance he's traveled is 8 meters. That's quite different from a displacement of 2 meters. So that is a huge difference. And make sure you know the difference, because one, you have to pay attention to the sign, pay attention to the direction, and one, you don't. So why don't y'all kind of pause the video for a moment and kind of look over your notes and see if you understand everything we've covered so far. If you have questions, jot them to the side and we will cover them in class. Alright, the next topic we're going to cover is the difference between velocity and speed. Velocity is a vector also. It has a magnitude, which means it has a number. 14 meters per second, 15 meters per second, 125 kilometers per hour. It has a value, it has a number, and it has a direction. Is it positive direction? Is it a negative direction? So that is what a vector is. It has both magnitude and direction, the same thing as displacement. It is defined as displacement per unit time. And please pay attention to the direction. That's very important, especially when we start applying these to some of your questions in your homework. So, the equation is V, velocity, is displacement, delta x, per unit time, divided by t. And the unit, the standard unit that we use here in class is meters per second. And that's because the standard unit for displacement is a meter, and also the standard unit for time is a second. So a lot of things in here will be worked in meters and seconds. So the unit for velocity is a meter per second. Well, let's take a look at our example, the last example that we did of this guy walking to the right here. Alright, so if I want to know what his velocity is, that is defined as displacement per unit time. So if he makes this trek, he goes all the way over to the 2 meter mark, comes back to the -1 meter mark, and he does it in a time of 10 seconds. So make sure you write that down. He does it in 10 seconds. What would his velocity be? Well, according to the equation, velocity is displacement over time, so it's 2 meters divided by 10 seconds, so 0.2 meters per second. Pretty straightforward. It is displacement divided by time. Now, let's talk about what speed is. Speed is a scalar, meaning it only has magnitude, it only has a number. It doesn't have a direction associated with it. And it is defined, oh, there goes the lights, hang on. It is defined as distance per unit time. And again, it does not have a direction associated with it. And the equation for speed is distance over time. So let's go back to our example from before, kind of higher up on your page. Take a look. The distance this guy covered, if you remember, was 8 meters. So if I wanted to know his speed, I'd have to use the distance, not the displacement. So if I want to know the speed of that guy, I'd have to do the distance of 8 meters divided by a time of 10 seconds, which gives me 0.8 meters per second, which is quite different from the 0.2 up here. In physics, we rely on the velocity because it's really important that we know the direction of things. So I hope that's clear on the difference between speed and velocity. And currently, y'all are working on a motion mapping activity, and you guys know that you can get the velocity from a position versus time graph. So if I do a position versus time graph, and I have an example right here, let me show that to you. Position versus time graph. There's position, there's time. And here's a line. This line represents the motion. So if I graph data, if I collect data and graph data, I could get the velocity off a position versus time graph. And in order to do that, that would be the slope. So the slope of a position versus time graph is the velocity. And I'm hoping you're getting that from the graph matching exercise that you're currently doing. So that is a common question on the AP exam, and you'll find a few questions like that on your UT homework. All right, so let's take a look at this. This is also a position versus time graph. And remember, the slope tells you the velocity. So if I were to ask you which one of these lines has the fastest velocity, I'm hoping you'll choose number 1. Number 3 has a slope, but it's not as steep as number 1. So number 1 has the greatest velocity. Number 3, or object 3, is the second fastest, and object 2 is not moving at all. There's no slope here, which means there's no velocity. It's standing still. So this is another way to compare velocity without actually having numbers. You can compare the slopes of the line. Well, let's see. That's about time. I don't think I have time to fit in anything else. Your next video will be a video over acceleration. So stay tuned, and I will have that posted in a few minutes. Bye.